Okay, I'm going to use the ice cream example that we already analyzed before, and we talked about sort of the stable allocations of this game. And now I would like to calculate the Shapley value of each player of this ice cream game. So I'm going to find the Shapley value of player 1 first, and I'm going to use this equation because I think although it's less intuitive, it's in terms of calculation, it's more friendly. So what is number of players in this game? There are 3 kids, remember? So therefore, 1 divided by 3 factorial, but let's not leave factorial. 3 factorial is 3 times 2, so it's 6. All right. And then parentheses, I'm going to have this sum. All right. So for every coalition S, which doesn't include I. So, well, here I'm talking about player 1. So what are those coalitions? Well, obviously, empty coalition, all right? Not this one. Well, this coalition of player 2 only, player 3 only, not 1, 2, not 1, 3, because they include player 1, 2, 3, and 1, 2, 3 includes 1 as well. Actually, we will never use this because the grand coalition includes all the players anyhow. So we can just eliminate the grand coalition. And there's no other coalition of those players, 3 players, remember? So therefore, I have to do this calculation, this summation 1, 2, 3, 4 times. Okay, so here's what I'm going to do. I'm going to do it for empty coalition first. So if the coalition is empty, all right, what is the number of players in coalition empty set? Well, 0. So this is 0 factorial, right? I know that it's 1. If 0 factorial is not 0, be careful. Times this term, n minus 1, which is 3 minus 1, 2, minus the number of players in S, which is empty coalition, so 0, okay? Factorial, don't forget that. And then the coalition, player 1's contribution to the empty coalition, which is basically V1 minus V S, which is equal to empty. Okay? There you go. Plus, I'm going to do it with coalitions that have one element. One players. So it's basically 2 and 3. So these 2 coalitions. So how do I do that? Okay, so here's what I'm going to do. So S is equal to, this time, the number of S is 1. So it's 1 factorial. So what is this? N minus 1, it's 2 minus the number of S is 1 factorial. V of, so remember the coalition was 2 and I'm including player 1. So the 1, 2 minus V of 2, Okay, plus, I do the same thing for this S. 1 factorial, 2 minus 1 factorial, because the number of S is still 1. So for that reason, I just copy this part. V of, however, this time, it's not 1, 2, but 1, 3. 1, 3. Because remember, the coalition is 3. The only player 3 is in the coalition, so I include player 1 into it, minus V3, whatever that difference is. I think they're all the same. But anyway, what else? Well, now the last coalition, S, which is 2, 3. So how many players are there? 2. So it's going to be 2 factorial times n minus 1, which is 2, minus number of S, 2. So it's 0 factorial. And what do I have? V 1, 2, 3 minus V 2, 3. Okay, that's it. Okay, very good. So here, let me write this. So 1 over 6, parentheses. So 0 factorial is 1. 2 factorial is 2. So this is 2 times this. If you remember, if a player is alone he can't buy ice cream. So V of 1 is simply 0. V empty set is also 0. So this is 0 times this. Good. Well, this is 0. This is also 0. When player 1 and 2 form a coalition, remember, they can buy ice cream of the medium-sized ice cream, which was 750 grams. So this is 750. 1, 3, again 750. And then 1, 2, 3, this is 1,000. And 2, 3 is 500, if you remember. Okay, so therefore, the second part, 1 factorial is 1, 2 minus 1 factorial is 1. So this is basically 1 times 750 plus, what else? This is 1 factorial times 1 factorial, so it's just 1, times 750 again. Good. Plus, anything else? Let's see. 2 factorial times, 2 factorial is 2, 0 factorial is 1, so it's 2 times, what is this? 1,000 minus 500 is 5,000. Okay, so that's it. So what is that equal to? This is 0. 750, 750, 1,500, 1,000, 2,500 divided by 6. 2,500 divided by 6. This is what phi 1 is. In fact, this is what, according to Shapley's value, this is what the payoff vector should be for player 1. It should give him 2,500 divided by 6, which is, I don't know, but approximately 400. Okay? Good. Shall we calculate the others? Yeah, I think we can. I think we still have time. So now I would like to calculate, so let's write this somewhere. So phi 1 equals 2,500 divided by 6. Now I'm going to do player 2. But now I have to look at all the coalitions that excludes player 2. Well, it's this one, this one, this one, and this one. All right, so there's going to be 4. All right, well, let's do that. Once again, I have 1 over 6 multiplied. Good. When S is empty set, when S is empty set, so this is going to be V of 2 minus V of empty. So it's going to be 0 minus 0, 0 again. So I'm not going to write it. So I'm going to jump immediately to this case where S is equal to 1. All right. So in this case, the number of S is 1. So it's 1 factorial times 3 minus 1, 2 minus 1, 1 factorial. In parentheses, I have V, player 1 and 2 minus only player 1. Okay? Plus this one where only player 3 is included. Again, S is equal to 1. So 1 factorial times, again, this is 1 factorial, times V of, 2, 3 minus V of 3 only, plus this one, 1, 3. Well, there are 2 players, and so this is 2 factorial times n minus 1, 2 minus 2, 0 factorial, parentheses, V of, the coalition is 1, 3, and then 2 is included. So 1, 2, 3, minus V of, remember, coalition is 1, 3. So the marginal contribution of player 2 to coalition 1, 3 is this. All right, so that's it. So that's equal to 1 over 6 times, once again, remember these are 0. 1 and 2, their worth is 750. 2 and 3, their worth is 500. And this is 1,000, and this is 750. Okay, so I have 1 factorial times 750, it's just 750. Again, 1 factorial 500 is just 500. Plus 2 factorial is 2 times 1,000 minus 750, it's 250. So if you do this, it's basically 500, 500,000 And so it's 1750 divided by 6. All right, so phi 2 is equal to phi 3, which is 1750 divided by 6. Why did I say, oh, this is phi 2, I'm sorry. Why did I say phi 2? Oops, this is not q, this is phi. So phi 2 and phi 3 are the same. I leave it to you as an exercise, but remember the player 2 and 3 marginal contributions. I mean, do the calculation, you'll see phi 2 and phi 3 are exactly the same. So, according to Shapley, all right, then the final payoff, not final payoff, I'm sorry, the payoff vector and outcome of this game should be phi 1, phi 2, phi 3, which is equal to 2500 divided by 6, 1750 divided by 6, and 1750 divided by 6. Well, once again, if you divide those numbers, I'm not a calculator, so 2500 divided by 6 is approximately, okay, this is like 41667. This is 29167, again 29167. Again, it's like, I don't know if they, well, but the thing is, if you calculate this, I mean, this phi 1 plus phi 2 plus phi 3 is exactly equal to 1000, so it's efficient, it's feasible. All of them are positive, so they're individually rational. And so this is roughly what the outcome should be according to Shapley's calculations. Well, is it more fair than, remember, I argued that this outcome is stable? I don't know. I mean, player 2 and 3 are still getting the same share. But here it suggests, the Shapley value suggests less than this. And it suggests more to player 2 and 3. Well, I don't know. I mean, is this more fair than this? I don't know. Again, it's like fairness is, well, as you wish. It depends on how you define it, and Shapley defined it in that weird way. But as I said, it has very nice properties. We will talk about it later. One thing I would like to argue, though, is that, is this stable? Right? I mean, fairness is good, but is this stable? And the answer is no, it's not stable. How do I know that? Well, I mean, if you add these guys up, okay, I mean, it's less than 750. Right? So if you add them up, or if you add this up, this is less than 500. Because what is this? 0, 10, 5. So this divided by 6, all right? So 3500 divided by 6, that's, oh, I'm sorry, that's more than 500. Yep, I'm sorry. So player 2 and 3 are pretty happy. That's my mistake, I'm sorry. But these two, for example, or 1 and 3, so it is basically 50, 4250 divided by 6. That is 7, yeah, what is this? I don't know, let's check. 4250 divided by 6. Oh, 708. So 708 something something, okay? Forget about the... So what does that mean? That means these two guys can actually kick the third guy and form a new coalition, and they can actually share 750 among themselves rather than sharing 708. So if you check the definition of stability, this allocation, this payoff vector is not stable. The bottom line, well, Shapley value promises to deliver fair outcome, which in many senses it does. But the thing is, it's not suggesting stable outcome all the times. All right. So Shapley value can be different than stable outcomes.